Hello students, in this session I am going to teach you the 12 principles of green chemistry. So in 1994, an American scientist, Paul, coined these 12 principles of green chemistry, and he made sure that these 12 principles will help us making the entire globe a greener place. So let us see his principles in detail. The first one is prevent waste. Now this principle is so important and it has to be done in a very accurate manner. There are many a times we do certain chemical reactions which have certain byproducts, but those byproducts are completely useless. Let me give you an example of a physical reaction, that is burning of coal or burning of wood. When we burn the coal or burn the wood, what happens is we get our heat energy, we get our light energy. But after that, after the entire ignition and the combustion process is completed, what remains back are the ashes. Now these ashes are nothing but waste, which we need to prevent. And that is how we came up with cleaner fuels like LPG, liquid petroleum gas, which we use at our houses for the stove. When we use that stove, that particular gas burns up, it gives us heat and light. Mostly it gives us heat because it is used for the cooking purpose. And once we just switch off the stove, the gas goes off, but there is no residue, there is no waste. That was the first principle, one of the most important principles to prevent waste. Designed chemical synthesis to prevent waste, leaving no waste to treat or clean up. When I'm burning wood, that particular wood is going to give me some ashes. Once I get those ashes, now for me, it is important to treat the ashes or to clean up the ashes in certain way so that they don't get mixed with the rivers or the sea or the environment overall. In the same way, when I'm burning coal, again I'm left with ashes. I have to do something of those ashes. But when we try to prevent it, we design a chemical reaction in certain way that we do not get any residue. That is the best thing, because then we will not have to treat it with anything or clean it up with any other thing. Second is design safer chemical products. It is so important to have safer chemicals and safer products. They should be safe for the entire environment. They should be safe for the living organisms. They should be safe for the humankind. Design chemical products to be fully effective yet have little or no toxicity. Now, why is this point so important? There are so many products which are useful but are very toxic in nature. Let me give you an example of the skin products, the cosmetic products that we use. Now, there are certain products which we apply on our skin, and after that our skin feels lighter, brighter, and it glows. For example, certain foundations or certain concealers. But what happens is those products are hazardous and toxic for the skin itself. So when we remove those products off, what remains back on our skin are still those products which actually affect and degrade the skin. So we should design certain chemical products which are fully effective yet have little or no toxicity. They are not toxic in nature. The third is design hazardous chemical synthesis. Now, if you have hazardous chemical synthesis, we have to design them in such a way that we know what is happening and we can control it. If there are chemical reactions which are so hazardous in nature and we have no control over it, then it may lead to many hazards. It may be disastrous. Design synthesis to use and generate substances with little or no toxicity to humans and the environment. It is very important for us to understand over here we are not only putting humans into the focus but also the entire environment. Why do we put the environment into focus? Because we not only care for the humankind but also the other living species. For example, animals, plants, the flora and the fauna. If I'm putting any hazardous substance into the river, that river is eventually going to meet the sea. And what does sea contain? It contains corals, it contains coral reefs, it contains flora and fauna. Flora and fauna is nothing but the plants and the animals which live under the ocean. That means different kinds of fishes, different kinds of crabs, different kinds of other substances. The coral reefs, the plants are known as flora and fauna. So we need to think about them as well while we are thinking about ourselves and the entire environment. The fourth point is to use renewable feedstocks. And not only for feedstocks, for almost everything, we should try and use renewable substances as much as possible. So when it comes to energy, we should use renewable energy sources. For example, the solar energy, the wind energy, the tidal energy. All these are renewable in nature. So if I have a solar panel, the solar panel has the work of gauging all the sunlight and the sun rays and making sure to make use of it and converting it into electricity, which is a renewable energy. Solar energy is a renewable energy which is helping us create electricity. Use raw materials and feedstocks that are renewable rather than depleting. Now, I have two kinds of resources, renewable resources and non-renewable resources. Renewable resources can be solar energy, the sunlight. Every day it is going to come. For 12 hours a day, it is going to be there. And I can make as much of energy or as much of electricity I want from that particular solar energy. The second kind of renewable source is wind energy. Winds are continuously blowing throughout the globe. So when the winds are blowing very high, we can make a lot of energy out of it and we can store that energy. The third is tidal energy. There are turbines which are kept, and when the tides come or when strong waves come outside from the sea, the turbines run and create energy out of it. Again, that is renewable energy source because it is renewed. There are certain other non-renewable energy sources. For example, all the natural gas, the fossil fuels, the petroleum, diesel, LPG, CNG, all of these are non-renewable sources. If they are non-renewable, that means we have a certain stock there inside the Earth's crust and we are using it every day. Once we finish using it, we do not know what to do next. That means those are depleting feedstocks or depleting resources. We should try focusing on the renewable ones and not the depleting ones. Renewable feedstocks are often made from agricultural products or the waste of other processes. Depleting feedstocks are made from the basic fossil fuels, that is petroleum, natural gas, coal. All of them are mined. Mined means they are taken out from the Earth's crust. Now the Earth's crust has a certain capacity. It is not such that the petroleum will keep on coming every day even if we keep on using it at a very high level. That is not the case. And that is the reason why we should try focusing on renewable sources rather than focusing on the non-renewable ones. The fifth is use catalyst, not stoichiometric reagents. Now there are two things when we use in a chemical reaction. We put them on the arrow which is there between the reactants and the products. And anything which comes on the arrow is nothing but the catalyst or the reagents with certain physical environmental factors such as temperature or pressure. We need to start using catalyst and not reagents. Now what is the difference between a catalyst and a reagent? Whenever we use a catalyst in a reaction, the entire reaction happens, and after the reaction is done, we can easily take away the catalyst. That means if I'm using 5 grams of a catalyst to speed up the reaction, at the end of reaction, I can take back those 5 grams again. Once those 5 grams are taken out, the reaction has happened properly. So I can reuse that catalyst again and again. But that is not the case with the reagents. The reagents get used up and thus they are not renewable anymore. Minimize waste by using catalytic reactions. out a single reaction many times. They are preferable to stoichiometric reagents, which are used in excess and work only once. Catalysts can be used again and again. One particular amount of catalyst can be used again and again, but that is not the case with reagents. Reagents cannot be used again and again. Once they are being used, they are completed. For the next reaction, I will need a new reagent. The sixth is avoid chemical derivatives. Avoid using blocking or protecting groups of any temporary modifications if possible. Chemical derivatives use additional reagents and generate waste. What do we mean by derivative? Derivative is nothing but a type of variety. We should stop using different kinds and different types of varieties when it comes to chemical reactions. We are just blocking and protecting temporary modifications which are possible, but that leads to a lot of waste. Seventh is maximize atom economy. Design synthesis so that the final product contains maximum proportion of the starting materials. There should be few, if any, wasted atoms. Now, when we are talking about chemical reactions, we have to go to the atomic level. We have to go to that small level, the smallest level, the most minutest miniature level, and we have to make sure that even that does not get wasted. So if I'm using 5 atoms of sodium and 5 atoms of chlorine to form sodium chloride, I should make sure that I get 10 atoms of sodium chloride. 5 plus 5 giving me 10. Even a single atom wasted in one reaction will lead to a huge wastage when the entire reaction happens at a bigger level, at a more volumetric level, at a commercial level. The eighth principle of green chemistry is use safer solvents and reaction conditions. Now, what do we mean by solvents? Whenever we are making any kind of solution, a solution is made up of two things: solute and solvent. For example, let us take salt and water solution. You're taking water, you're adding 2 tablespoons of salt and you're mixing it up. What happens over here? The solute is my salt, the solvent is my water, and salt and water mixed together forms the solution. Let us take another example. Sugar and water. So when we have sugar mixed with water, the water is my solvent, sugar is my solute, and the entire solution is known as sugar-water solution. We need to make sure that the solvents we use are safe. They are not hazardous in any way. And also we have to make sure that the reaction conditions we use are safe. We cannot have explosive reactions happening at higher temperatures. That will lead to lesser safety. Avoid using solvents, separation agents, or other auxiliary chemicals. If these chemicals are necessary, use the innoxious chemicals. That means if it is absolutely necessary, then use the noxious ones. The ninth principle of green chemistry is to increase energy efficiency. If we are using certain kind of energy, it is very important for us to make sure that it is efficient in nature. The efficiency of that energy has to be there. That means from that particular amount of energy, we have to reap out as much of work as possible. We have to reap out as much of benefits as possible. Now, why do we do so? We have to do so to make sure that the energy is being used completely and is not getting or being wasted. Run chemical reactions at ambient temperature and pressure whenever possible. The temperature and the pressure should be ambient, the temperature and the pressure should be normal. It should not just flare up at very high temperatures or go down at low temperatures. If the temperature and the pressure is proper, energy efficiency will increase on its own. The 10th is design chemicals and products to degrade after use. Design chemical products to break down into innoxious substances after use so they do not accumulate in the environment. Now, in short, it is trying to say that be as biodegradable as possible. If there are certain wastes or certain kinds of chemicals coming out of my particular reaction, it is our responsibility to make sure that those waste materials are not filling up the entire environment. So, now to do that, what should we do? We shall use biodegradable materials. So, if I have any kind of waste, but that waste itself is biodegradable in nature, that means it can be easily be degraded by the environment itself, then we do not have to worry about it at all. It is fine for us if it gets degraded on its own, by its own self. But if it is not biodegradable in nature, it will start accumulating in the environment. It will start producing waste. And one of the most common examples of this is plastic, especially the one-time use plastics, the plastics which are not renewable or not recyclable. Those plastics lead up to a lot of waste. They are just filling in the environment. Thus, we have to make sure that we use the products which can get degraded on their own. The next is analyze in real time to prevent pollution. We have to prevent pollution right now in the present tense. Thus, we have to make sure that we analyze things in real time. We analyze things in such a way that they happen right now. Include in process real-time monitoring and control during synthesis to minimize or eliminate the formation of byproducts. How important and how necessary is this? If I am making a certain reaction or if I am forming certain reactions, it is very important for me to make sure that that reaction has very little byproducts or very little waste. If I make sure that the waste is very little, so when the waste is generated, it can be easily collected over and it can be easily used later. And if it is biodegradable waste, then we do not have to worry about it at all. But if we do not take that presence of mind or that particular thing into our own conscious, then what happens is we end up generating a lot of waste and then we have to deal with that particular waste. At times, dealing with the waste is also not advisable because it takes up a lot of energy and a lot of money. There are many companies and factories which have to bear with a lot of losses because that particular waste has not been handled properly. Thus, it is important to analyze the real time and prevent that particular kind of pollution. Now, the 12th principle of green chemistry is minimize the potential of accidents. Now, there are so many cases we have heard which has led to many hazardous accidents of different chemical companies. There are gas leaks which happen, and because of that gas leaks, there are people in that particular city who died just by breathing that gas. There are so many oil spills that happen. Now, when an oil spill happens, it not only affects the environment, but there is also wastage of that particular energy resource. There is also wastage of that particular oil. So when an accident happens, it is not only wastage of resources, but also degradation of environment, and then we have to put in more resources to make sure that that oil is taken away and not degrading the environment more. And in this process, there are so many human beings, there are so many plants, there are so many animals who can also get affected and die. An accident has many after effects, and some of them are really expensive, not only in terms of money but also in terms of lives of human beings and the environmental impact and the overall environmental effect. Design chemicals and their forms. For example, I have solid, liquid and gas. To minimize its potential for chemical accidents, including explosions, fires, and releases to the environment. So, if there is a big gas chamber and that particular gas chamber explodes, then there are many people who will get affected by it, many lives will go. Even fires are very crucial. The fires can just spread out leading to many losses. And any kind of releases, that means gas leaks, release of gas in the environment, may lead to other problems as well. So these were the 12 principles of green chemistry which were coined in 1994, and these are extremely important because they help us not only make the environment better but also help the chemical reactions be much more efficient. Thank you.